Hello and welcome back. So now we'll look at an example using Wireshark to analyze malicious backup. We'll look through like how we can use this Wireshark filters and our understanding of different protocols to analyze some packets, to analyze like this network communication and try to find some malicious activities and try to answer the questions that we have been asked in the first place, like what's this attack, how it's happening, what's happening on these machines, what we can know out of this backup, what's the malwares, what's the stage, what's data being exfiltrated, and so on. So let's take a look at this backup. So this backup I downloaded from malwaretrafficanalysis.net. It's a blog actually that includes lots of different backups and different spam that he was able to collect and different malwares. And this one was pushing a malware called Naimame, I think. This is how it's pronounced, maybe. But this malware is, I think it was a banking Trojan. Anyway, we will look at the backup and see how this what's happening inside this machine. So here we can see like in every row it represents one packet that was sent. Here's the type of protocol, like here's TCP, so we don't know what's the application layer, maybe there's no specific application layer. Here you can see like here's synchronize, ACK, and then ACK. So this is like a connect. Here's like HTTP, he starts to request some HTTP requests. So here he starts to send data, the communication is established, and he starts to send requests. And there's an acknowledgement and then response and then an acknowledgement of the response. As we know about TCP traffic, we can see here like some DNS, and DNS, as we know, it uses UDP as transportation protocol, the way to transfer packets and communicating between client and the victim, or between like client and server. Let's say we still don't know if it's victim or not. And here we can see like the DNS protocol, and here in Wireshark he tells you this is a standard query, and it was querying for this domain. And here's like a standard query response, and here's the response. And you can see here like what's the source IP, the destination, here's the response, and it was this IP. So it gives you all the information. Not only this, if we looked here, we can see like all the information. So here's like the Ethernet protocol. It includes like the MAC address. So here's the first MAC address, is the destination, here's the source, here's the numbers, it's like the name of the machine. And here's the type of the IP, because we have like IP version 4 and there's an IP version 6. Apart from what is the meaning of this, it just describes the next protocol. There's two versions, and IP version 4 is like a small set of IPs that doesn't represent how many devices are in the world right now. So people are starting to move into IP version 6 to be able to contain all of this number of devices that's communicating and have an address for each one of these devices in the whole planet. So as we know that the internet protocol or the IP is basically represents an address. So if there's too many places to write an address for, you have to extend your address format to be able to include everyone. So anyway, this is the IP, and here we can see that here the time to live, as we said, like 128 could represent Windows, let's say, or Linux. And here like the source IP and the destination IP, and tells about the next protocol. So it says that the next protocol is UDP, and for the UDP we can see here like the source port, the destination port, the length of the data, and so on. Here, as we know that UDP doesn't have lots of information. It's not like TCP. If we look like TCP packet, we can see like source, destination port, sequence number, acknowledgement number, and the length, of course, and the flags. You can see like here, like all urgent, acknowledgement, push, reset, synchronize, finish, and so on, and lots of different options. So like TCP has more information, as we know. And after that, after the UDP protocol, we see the domain name protocol. So if we go to the query one, we can see something called flags, which tells you, oh, this message is a query, and some other information about the message. And it's one question, just one domain that we want to know, and the query is this domain. This is the name, and we want to know what's the IP of this domain. And the answer is basically the same protocol. Here's the response. The master is a response, so this flag is set by 1, and one query, one answer. Here's the query, the same domain, and the answer is the name, type, class, and then the others. And we can see like the time to live is like 5 days, and the address is this address. This is the IP, and we can see that he's directly connected to this IP and starts to establish a TCP connection, and then start, after the connection was established, he starts to send like HTTP requests. We'll look at HTTP requests, but before this, let's start to analyze this protocol, and let's start to use some of the Wireshark filters. So one of Wireshark filters is basically, we can write here the name of the protocol. Like if we want to see the DNS protocols, we just write DNS or HTTP or IP, all the protocols that has an IP, or all the protocols that has UDP, and so on. So if we write DNS, we got all the requests and responses here. If there are too many, sometimes there are too many that we can't see, and we only want like one of them. Like this is like the request and the response, request and response. We want just like only the response. We can go here, and we can go to this flag that says this master's response and say apply a filter selected. So we only want to filter that has only the packet that has this flag is on. So we can put it here, and we can see like only the responses up here, and we can add also some other things if we want, like and UDP.port equal or like I don't know, maybe destination port, or like maybe port equal 53, sorry, equal 53, and it will be the same because all of them has port 53. Of course, if we put something else, it will be different. But here we can see like we can merge some filters together, and we can see here like in this one there's multiple domains, and all the domains are not recognizable websites, like websites that we may be malicious or maybe legitimate. We can take a look on the requests. So to speed up, here we can write this IEP and search for it, or we can just take this one and say apply as a filter. Here he imagined that he wants to see all the DNS responses that equal to this IP, but we actually want to see all the communication to this IP. So we change this one into IP.address. So we want all the communication to this IP, all the communication, whoever like it's sent to this IP or received from this IP. So we say IP.address with this IP, and we see here all the communication. We can see basically synchronize, ACK, and then ACK. So this is like the TCP handshake, and then the GET request, and we can see like a GET request, and then acknowledgement, and then the response, and then acknowledgement, and then finish, and so on until he closed the connection. So let's see how this data looks like. We can see here in follow, and he has here like something called TCP stream or HTTP stream. They're both the same. We can click on TCP stream, and we will see all the requests, all the HTTP requests, like get this path, we accept all types, language, user agent. It's very important to look at the user agent if there's something suspicious, and the name of the domain as the host. So this is the host, there's no referrer, looks like, and this is the website that he wants to access in this IP. And we can see here the response and the code 302 is basically means redirect. So it redirects him, it set a cookie and redirect him to this location. So we can see here like this domain, this is the new website, and he will be connecting to this domain and then getting the IP and then sending a TCP request. We can speed up and imagine like if you will request something, if you will request this URL to this website, we can just search for any for a host, for any communication that has the host is this domain. Like if we looked up here in the GET request, we can see here in the GET request, here's the host and the name of the website. Let's imagine if we want another website, which is the website that he's redirecting to, this website. We can actually search for any request that has this as a host in the GET request. So we can, or post request, whatever. So we can follow, okay. We can go here, go to this host and apply as a filter. He will give you this GET request that has this was the host in the request. We can change it to the other website. This one. So we have got the GET request that has this domain as a host. It's just a way to speed up rather than going to DNS, getting the IP, and then start to see what's the IP, and then we search for the IP, and then we get the whole data, and then we can just follow TCP stream, get the whole request. So we can see here like get the host is the new domain, and then the response is also another redirect. So we can take this one as a domain to search for, and we can see here the redirect is invoice.document. So it looks like it was basically an email, and he was telling him this is where you can download the invoice, and starts to redirect him to one URL to another until he's going to download the invoice. The domain looks maybe suspicious and strange to have an invoice in WordPress. This is like WordPress content, so it's strange to have like an invoice in a WordPress website. But let's search for it. Let's try to take like similar to the previous request, HTTP host, and search with the new domain. So we put the new domain, we got the request, follow TCP stream, and we can get all the data. And we can see here like he started to send him like a Word document, and this is the invoice.doc. So this could be a malicious document, could be a normal document. We have to figure out. We can dump this document out of here, and basically we can like save all of this data up here. I don't know if you see it, like we can save this data up here anywhere. We can show it like as a hex dump or C array of code, or whatever way we want to see it, and we can export it, and we can see here like all of this document, and we can start to see like some of the text, some base64 information. Maybe it's a normal document, maybe it's suspicious. We can look at the next domain. So this is the invoice, this is the file was downloaded. We can start do some analysis and see if it includes any like macros or something, and we can on the bcap look at the next DNSs. So we stopped until here, and now we want to look at the other domains because they don't look like normal domains. They look a bit suspicious. So let's take a look. We go to the response. We filter by address as we get used to, and then follow and then we go here and choose we want all the communication that was done to this IP. So IP address. Here we have all the HTTP requests. Here's the TCP handshake, synchronize, ACK, and so on. If we follow the TCP stream, we can see there's multiple requests. And here's hit. I'm not sure why he was using hit at the beginning, but anyway, he's getting this PNG picture. And here the response, content type MG, and then here we can see like MZ file, MZ, SAS with MZ, this program cannot run DOS mode, and it looks like this is an exe file. It's not actually an image, it's not a PNG picture. We can see here, like as we said, the MZ at the start, this program cannot run DOS mode, PE after, and we can see like lots of data. So this looks very, very suspicious, and we can see like he starts to send more and more data. I think it's the same picture. So he's basically getting the remaining of the file little by little, all the file and all the information, until he sends the full exe file. And this is something very, very suspicious, and could be like the first stage of the malware. And we can look here, like he's not using a referrer, but we can see here like user agent is Microsoft Bits. This is not like normal user agent. We usually see like Mozilla or Chrome or something like that, but Microsoft Bits is something suspicious. And normally Microsoft Bits is used to represent mostly it's something like something intelligent. It's a long name, but this as a user agent is seen more in Visual Basic scripts that's running as a macro inside a document. So it's very, very suspicious that it could be linked to this invoice.doc, because the user agent here is a common user agent that will be used by a Visual Basic macro. We can actually take like a GET request, go to the user agent and use it, apply as a filter this user agent. We can see here like http.useragent equal this, and we can see all the requests. They are all the same picture. So it's basically, it was a partial content, so he was trying to get the full file, the full exe file, and you can see like all these requests was done by the Visual Basic script macro. And if we continued, like this could be the link to download the exe file, and this domains could be actually part of the malware. So maybe the malware have been executed already, and now this is the domain, the CNC that the malware is using. We can check like here there's multiple addresses. Let's take the first address. So the first address, IP.address, we see if there's any communication. There is nothing. We can actually try to search for like a host with this one, if there is like a host, because we can see here like there's one query, but there's like 11 answers. There's 11 IPs for this one. There's 11 different IPs. We can check each one of them, but we can like search for it as a host. So if we copy the name of the domain, or like we can just apply a filter here just to copy the name of the domain, and we can say like http.host equal this one, so there is no information. Let's try to take TCP and see if there's, or let's look at, here's after all the partial content. We can search for HTTP just to speed up. Like HTTP, we can filter out different things, and we can see here like some post requests. So after all the images, we can see here like this is a different request. So we can try to look at this one. We can see like head, and then we see it as a host. Well, this is not this. This is the same request. Sorry. So HTTP, here we have the PNG requests, and then here's something different. So we can follow this one. This is still part of the, so it's basically, it's like all try and error. So you can see like here the head request to the index, and here he changed the user agent. And if we looked at the next requests, we can see like here a post request. Let's take a look like where this post request is for, and it looks like he's sending some data, and looks like this data could be base64, could be encrypted data. If we copy this data, go to like base64 decode, there's a website I used to use for decoding base64. It's the worst website, but I kinda get used to it. So it doesn't look like this data could be understood. So maybe it's encrypted data, maybe it's a DS data, DS encrypted, or wherever the encryption is. And the malware analyst has to understand how this communication actually works, and what is this information have been sent, and what's this, is this the comment, or what is this data? And as we were just browsing the HTTP, we didn't know what is this IP that we are communicating with is actually connected to which domain. So we can just check here, and like we can take the IP, take this IP, the destination, apply it as a filter, and now we can look at if there is any DNS response that include this IP. So we are actually doing the opposite of what we used to do. So we can do DNS.A, so we don't know if there is an IP for this one. And we can even, like, if we looked back on the DNS, we can see if there is like any response of them if we want to check, but it looks like there's no known domain for this one. So maybe this domain, maybe he had an IP plus domains he was querying. If we looked at other HTTP, so here we can even like we can search for any request that doesn't have a host. So maybe it was a request to an IP or a CNC that's just an IP, not a domain. So we can look here and we can say like, if we said like http.host, we'll give all the requests that has a host. But if we said http not host, it will give all the requests that doesn't have a host, even the TCP ones or UDP ones. So we can say http and doesn't include a host. He is giving us responses. We can look if there is other requests, or we can just say like and http dot, let's say, method. I don't remember, to be honest. or maybe no status code. So no status code, so we can see like apply as a filter. So this is the response code. We can say like no response code, HTTP, and no response code. And we can say also and no HTTP host. So we can find it this way. So we are like sieging, going around him from every direction, and we try to make sure that there's no request that doesn't have a host, HTTP request that doesn't have a host, and it's not as a response as well. And this is basically a way to get more information. And if we turn it back to the DNS, we still have like some domains that we still don't know what these domains are doing. Did he request them, and did he use the IP? So we can check this one, as this is only one IP. We can here check like the 14 ones if we are if we have time. Here like IP.address, and we can see that there was some post requests that was actually done to this host, but here it's so strange. He's using different host to send the request to this IP, and this is very strange. So he was querying the domain, he was getting an IP, and he was sending a request with completely different host name and completely different application, and this is something very suspicious. And again, we can see like this encrypted data being sent, and some encrypted data have been received. So one of our tasks is to understand what's actually sent and what's actually received. The only remaining here we didn't understand is this this IP, and it could be like the one that we saw with the one we saw after this partial content, like after this, all of this, after we reached here and we saw like completely different hosts up here. This could be actually as an IP, is the IP of this one of the IPs of this DNS request. Well, we can check, and we can check each one of these IPs if there's any data have been sent to any of them. So this is basically like a simple demo. We have seen here in this demo like some redirects up in the beginning. We understood how we deal with filters. We saw as well like how he was downloading a document file. We saw requests using Visual Basic Macro inside these documents to download another stage or download another part of the malware. And then we saw some IPs and some root requests being sent using the IPs of these domains, or another IPs that are saved inside the malware, to be able to extract, to be able to send and receive information related to the machine and exfiltrate lots of data in an encrypted form. So our next task is to basically decrypt this data and understand what's happening on this machine. So that's it for today. We have understood lots of information about this attack. We have seen like the first stage, the second stage. Could be the first time he clicked on this link through an email. If you have a full backup, you may have seen also the email. Maybe not, but at least you know that he clicked somewhere to download this invoice, and he was using social engineering. They were able to trick him into downloading this invoice, to open it, to start running the malware and pushing the malware name inside the machine. So this is for today, and In the next part of the module, we'll look at digital forensics and memory forensics, and we'll dive more. So from here, we were able to, like here we can see all the IPs that's connecting, that's requesting this. If we looked up here, like let's say, and we only want the query, we only take the query, so we can see all the machines that have requested these domains. And if there's multiple machines, we can see that these domains are actually this IPs are actually IPs of infected machines, and we need to do digital forensics. We need to do some forensics over these machines and try to extract the malicious samples from these machines, understand how this data, how this attack started, and what happened after, and what changes happened on the machine itself, physically on the machine. So this is the next part, and this is the next module, and this is the next step in the incident response. So after you got there's an indication of compromise through the logs, you go into the PCAP, you understand more about the attack, what's being sent and what's being received, and what's the infected machines. And after that, you go to these infected machines, you take an image from the hard disk, from the memory, and you start to analyze them to know how this attack has actually happened. So that's it for today, and see you in the next part of the module.